All right, so from the interactive graph we just saw, we said that the sine curve, y equals the sine in terms of theta, okay, where this is going to be our theta going across this way. The y value is the sine. So if I start here at this point, there is no y value. Okay, it's 0. Then as I start to move around the circle, the y value does what? So if I take all those little lengths and I move them over here, it's increasing. Everybody okay? Then I move over here, the y value is going to start doing what? But still positive. Very good. I'm above the x-axis, so it is decreasing and getting shorter, but it's still positive. So I move those over here. Okay. Now, when I go down here, the y's become what? Negative. Why? Because I'm below the x-axis. They are negative and getting more and more and more negative. They don't get more and more negative at a linear rate. That's why it turns out to be a curve. Okay. And then when I get to this, now it starts to get what? Still negative because I'm going down, but it's starting to get shorter, yes? Okay, my graph is horrible over here. But that's where those come from, okay? I did a really crummy job, but you get the idea? What? Do you like this way of explaining it? I kind of like this way of explaining it. It took me 30 years to perfect this way of explaining it, but no. Okay. Yes, if we actually measure, if we made this radius 1, okay, if we made this a radius of 1 right here, there is no y, we haven't gone up or down, so we're at 0, 0. If we rotate around to like here, you'd be halfway, so you'd be in the middle of something like this. But when you get right up to here, you've rotated how far? Pi over 2, and you're finally at the maximum, which is a radius of 1. So the ordered pair up here is going to be pi over 2, 1. You need 5 ordered pairs for me on this graph by memory. Okay? Eventually, you're going to have to do shifts and stretches later today, as a matter of fact. But on the unit circle quiz, on the back, it will ask you to draw 1 period of the sine graph with 5 points labeled. And these are the 5 you need. 0, 0, pi, 1. Now, as we go around to here, is there any y value here? What's that ordered pair? Yep, in radians, it's pi, 0. And that corresponds to right here. As we go down here, somewhere in here, we'd have negative, but it's not to 1 yet. But we get down to here, and you're down to what? The degrees we have turned is 3 pi over 2, and we're down a radius of 1, which is a negative 1 when we are talking about the direction. And then as we rotate around, it eventually gets back to 0 when we've moved all the way around. Okay, we've rotated once around 2 pi, and it's at back to 0. Better? And that's also why it repeats, because we can't go anywhere else. We just start doing it over and over again, and that's why the graph looks like this. Okay? Yeah, not very nicely drawn. Matter of fact, I'm going to redraw this, and just, this is what the graph would look like if I drew just a little bit on either side of 0, 0. Do you remember what Is that even, odd, or neither? What's the definition of, what kind of symmetry does it have?
Origin.
It has origin because I can turn it over and it looks the same, yes? They could not get that last period, so I drew it on this piece of paper. But yes, it looks the same? Okay. So if it looks the same upside down, when it goes through the origin, it means it has origin symmetry, which is? Anybody remember? Odd. It is odd. What does even mean? Y-axis, okay? And this one does not have y-axis symmetry. All right. Ready to try this? What is the y value? No, we just did y. We're doing cosine. Y equals cosine of theta. This is theta. Cosine is x. Okay, if I start right here, what is the x value right there? 1. So this is 1, 0. And I start over here at 1, 0. But now what we're talking about is the x value. So this is the longest x value. As I rotate around, look what happens when I put my little things in here. What's happening to these x's as I go up? I'm not actually going up, I'm going around, okay? But the x values of each of those points is getting shorter and shorter. So those correspond to these values getting shorter and shorter. I didn't draw that well. Because it should actually be curving like this. All right, now if we're talking x values, what's happening to the x values over in quadrant 2? They're negative and they're getting longer. So I'm going to do them a different color to show that they're negative, okay? So the next thing that happens is they become negative and get longer. And then what happens when we get past where they get the absolute longest was what point out here? Pi, right? They got the longest. Then after pi, they're still negative, but they start to get what? Smaller. Until there's no x at all. And that's at, what's this spot where we've gone 3/4 of the way around called? All right, and then they start to get longer again, but what's going on is they're now getting more and more positive, yes? All right, so it should look like this. I made mine, parts of it aren't so bad. All the way around was 2 pi, and the same as at 0, the ordered pair was, or at 0 it was up at 1, at 2 pi it's up at 1. I don't know, I started to say that wrong, I think. Okay. The longest it got in the negative direction was 1, and that happened at pi. And we said at 3 pi over 2 it was at 0. And where's the other 0 then? Halfway between. Somebody fix me. What's my problem? There's one on there that's wrong. Thank you. No wonder I was getting all messed up. When we've gone around 0, it's up at 1. I had that written backwards. Totally backwards. All right, what's this point in here? Oh, my head is hurting. This is over 0 and up 1. This is, we've rotated 0 radians. and the unit out. You don't want to repair here is the problem. At 0 radians, the x value was 1. Okay. I'm like writing it one way, one place, and one way the other. Just kidding. Okay. We missed pi over 2, comma 0, right? There's no green showing when we get up here. I was doing well for a minute there, and then I got totally confused. All right. If I continue to draw this, what kind of symmetry will this have? If I draw it a little bit on either side, I can fold it in half this way, which is which way? It's y-axis symmetry. I can fold my paper in half. If this were one period and it had, just kidding, I have to just redraw it. It's not going to work. If I draw it here, I can fold it in half this way and it'll match up, yes? That's y-axis. Okay, make it sure. And y-axis symmetry is even. You guys have questions? Did I do something backwards? That's a great question. So why did this one start at 0, 0 and this started at 0, 1? This one we were measuring the x's and there was no height to it at all. On this one we're measuring the y's and there's no height to it at all. Cosine is x. When we start out here, we're all the way out here at 1. There's no height though. So the x is 1, but the sine value had how much height there was, and there was no height there. Okay. All right, guys, last one, tangent, and this is the only time we're going to talk about tangent today. We're not going to graph any more tangent functions. What today? The tangent is sine over cosine or y over x. What else is y over x? Yes. Change in y over change in x is slope, right? So the tangent is really measuring the slope. Okay. When I start with this point here, what is the slope of a horizontal line? Okay. Slope at 0 is 0. As I move around, the slope is getting, now just think about the tilt of the line. Okay, I could walk up here, then it gets a little steeper, then it gets a little steeper, then it gets a little steeper. Now, actually at 45 degrees of turn, at 45 degrees, think about that for a minute. If there's a 45 degree stair here, it went over the same amount, right? So the tilt of the line is over the same as it is up, so that would be 1. So it's going past 1. Do you see it keeps getting steeper here? It's getting steeper and steeper past 1. It could get almost straight up and down. It's getting very, very steep. So that I don't want to make that look like a line. The slope of the line is increasing and getting really, really big. Then the slope of the line gets to here. What is the slope of a vertical line? Undefined. So the slope is undefined. So there's an asymptote in the graph at, what's that spot? 90 degrees or pi over 2. Now, watch what happens to the slope of the line over here. It's really steep, but it's really, really what? It's really downhill, yes? If Hofbar tries to ride her skateboard, this is not going to go well down that thing. If we get to here, I might be okay, right? If it was really flat? Yeah, right. So it was really negative, and then it got closer and closer to being flat. Okay? And then it got back to horizontal, and at horizontal the slope is 0. Okay, this is what the tangent graph looks like. Because we're actually done, because now if I go down into this quadrant, isn't that the same exact line? So the slope is the same all the way along that line, right? So the slope just starts to repeat. That's why the slope repeats, and we're really already covered one period. The tangent has a period of pi. The next time it's undefined would be when it's vertical, which is not 2 pi, it's what? Where's it vertical? 3 pi over 2. So the next time it's undefined would be 3 pi over 2. The next time it's 0 would be 2 pi. Yes, yes.
Is there anything that would example something
that makes a tangent? It would have to be related to the slope as you rotate around. So I don't know an answer off the top of my head. You know, if you had something that was rolling around the outside, yes, the slope of that object or something, yeah. So Ms. Gupta could answer that question much better than me, because it does take calculus to get that to that point. No, the difference is the cubic doesn't have an asymptote, and the cubic keeps growing wider and wider and wider forever. This will just get closer and closer. It's really hard for me because, yes, the same with a parabola and a hyperbola we're going to talk about later. Okay, a hyperbola is this shape, and I want to say, well, that's the same as a parabola, just at a different angle, right? But it's really a little bit different because a parabola gets wider and wider and wider, and a hyperbola just approaches those asymptotes. So it does get wider, but it doesn't get infinitely wider. That's the difference. All right, guys, even, odd, neither. Do you see it does go through the origin? If I tip that paper upside down, what do you think? It is going to look the same. Let me draw it, because I see some of you arguing.
I don't believe. I need evidence.
Okay, there it is, right? If I flip it upside down.
Witchcraft.
Okay,
Where's the choir?
so it is origin symmetry, which makes it an odd function. All right. Woo! That was my segue. We're moving. Everybody okay? We're moving back to worksheet, this is 10. So this is worksheet 10, side A, maybe, we're going to talk about next. I'm going to try to do this a little more efficiently than I did in the other classes. They literally broke spaghetti strips, like how I drew those little lines.
Oh.
And then they measured them off, and then they moved them over and put them this way, and so they just used pieces of spaghetti instead of my little sketches. Okay, I'm going to go through this quick. You don't need to write anything down, just look up here, okay? The domain of a sine and cosine function are infinite, because that pattern will repeat forever to the left and to the right. Does that make sense? But the range, it will only ever go, if we don't change the amplitude, they will only ever go up as high as 1 and as low as -1. Both of them. The sine graph has a y-intercept at 0. We talked about why that is. And the cosine graph starts at its peak of 1. Or has its intercept at 1. The x-intercepts, this will cross at pi, 2 pi, 3 pi, which they write every multiple of pi, and then instead of saying where n is any integer, they say where n is an element of the set of all integers. Same, easier way to write that, I guess, but it's confusing to me. This one crosses the x at pi over 2, 3 pi over 2, okay? So it's pi over 2, and every additional pi after that. So they say plus pi n. They say where n. Yes. This actually 1, 2, no. This is actually wrong. This isn't written correctly, I don't think. Okay, anyway, we're going to go on. Continuous. Is this graph continuous? What's not continuous that we talked about a minute ago? Tangent. Tangent has undefined places, yes? So tangent is discontinuous. All right, symmetry we talked about. Origin, so odd. Y-axis, so even. You don't have to know this, but again, the maximums occur at pi over 2 and every cycle after that, so every period after that, or 2 pi. The minimums occur at 3 pi over 2 and every 2 pi after that. But on this one, the maximums occur at 0 and every 2 pi after that. And the minimums occur at pi and every 2 pi after that. Okay? Last thing, because this oscillates between -1 and 1, it has no limits, okay? It has no end behavior, because anywhere out at the end, it will continue to go up and down. Claire?
For the range, is it possible to have, like, a first value that's a different number than the second value? Like, can it go, like, higher on the top and then not as, like, does it always have
Yes.
to be, like, -1, 1, -3, 3?
That's a great question. If we shift the whole graph up, it could be 0 to 2. Or we could shift it up a whole bunch, okay? Yes. No. The range of a normal sine and cosine will always be -1 to 1. When we start shifting and stretching, then it throws the whole ball game, okay? But the domain will stay the same, but the range will change, the maximums and minimums. So, just for fun, we're going to talk about that. Okay. The difference in these two forms is really important. My understanding from the other classes is that in Honors Algebra 2, you used this form, okay? So A is going to affect the amplitude. You have to take the absolute value to find the amplitude. B affects the period, but remember how when you stretch the period out, it slows the piston down. This is a reciprocal relationship. C, what does anything in here do, guys, right? When I had this question, what did that do to the parabola? Inside would be to the right 4, okay? It's to the right 4. So I don't know why they write this with a plus. I usually write it with a minus, and then it's the opposite of C. Okay. And then D is the vertical shift up and down. When we put a +5 on the back here, it shifted it up 5. So this is the vertical shift. Now, when they leave it multiplied in here, which is the way they teach it in trig, then because you have not factored it out yet, the phase shift left or right is actually C over B. Because, let me explain that. Write this down. I don't need to write this down. I'm writing this down. If I take out a 4, how do I decide what goes at the end? I divide it by 4 and get 2, yes? So if I want to take the B out, I have to divide by the C by B. So when it's in unfactored form, the phase shift is C over B. See here how it was, the B was inside, so you'd have to factor it out. That's why I don't teach it that way. I like it factored out because it's much more, it goes with what we did when we did parabolas. All right, now I talked about the word amplitude. The definition of amplitude is half the distance between the maximum and the minimum, or as it's written on your sheet here, it's max minus min divided by 2. Will you please remind yourself this means it's always positive? What does it mean when you put a negative out in front? So if I had a parabola that was x squared and I put a negative out front, or even a negative 2x squared. It means it's flipped over the x-axis, yes? So the negative does something totally separate from the amplitude. It doesn't stretch it. The negative reflects it. All right? The next is the period. It says the period of a sinusoidal function. By the way, sinusoidal function means both sines and cosines. Rather than saying the period of sine and cosine functions, they just call them all lumped together, sinusoidal. The other reason for that is the cosine is really just the sine shifted over. If I go back here real quick, do you understand that if I took this black curve and shifted, or the axis, doesn't matter, and shifted it over, that becomes a cosine graph, right? Okay, so therefore they are really totally related to each other, and you could just do shifts to find them. So they're called sinusoidal. Anyway, it doesn't matter if it's factored or unfactored, the period is going to be 2 pi over b, as long as it's a sine or cosine. If it's a tangent, it's different. So period is 2 pi over b. It's a reciprocal relationship. Okay? The bigger the b value, the shorter the period. Frequency, we're going to do very little of, but it is the reciprocal. We saw it in the music video a minute ago. Remember it talked about frequency briefly? Frequency is just the reciprocal of the period. You don't necessarily have to do 1 over the period. You can just flip it over. Okay, so it's the reciprocal of period. The phase shift, there's a typo on here. If it is unfactored, it's C over B. But if it's factored, it's C, or the opposite of C, depending if they wrote it as plus or minus. They wrote it plus here, so it'd be minus C. Okay, that's a typo on your sheet. Did you change that? The phase shift is the opposite of the C from the equation up here. It's actually not from that equation. Kidding. If we wanted it to be C, we'd have to do this. And this is the unfactored form, then it would be C over B. All right, last one, vertical, almost last one. Well, I guess it is. Last one, vertical shift is when you take the whole graph like this and you move it up. Okay? Move it up like that. Then to find the vertical shift or the midline, you have to average the top and the bottom. So this is an average of the maxes and mins becomes the vertical shift D, and that line through there is going to be y equals D. And remember, that's just D from the back of your equation here. All right. We don't have a great deal of time left. What I want to do, I'm going to talk you through this one super fast. And then we're going to skip to some on the back because the ones on the back are easier, okay? So I'm going to talk you through this icky one. First of all, I'm going to rewrite it in factored form. What is bugging the x right now? It says divided by 4. If I made that a multiplication, it would be a 1/4. So I want to factor out a 1/4. To take a pi over 3 and divide it by 1/4, or factor out a 1/4, remember factoring out is dividing, I would have pi over 3 times, flip this over, 4 over 1, which would become what? 4 pi over 3. That's disgusting. And then there's a plus 2 on the back, okay? That's actually what they wanted us to write in this blank up here, was the factored form. My bad. It's supposed to say 4 pi over 3. Okay. The A is 2. The negative flips it upside down, which is the reason the graph starts doing this. Okay? It's upside down. The amplitude is 2 because it's the absolute value of A. I guess we could have written A as -2, and then the absolute value is the amplitude. It doesn't matter to me. The period is what? 2 pi divided by, what's B? B is 1/4. So 2 pi divided by 1/4 is 2 pi times 4/1, which is 8 pi. We'll talk more about that on the graph in a second. It's really hard to tell what's going on that graph right now. So it takes 8 pi to finish. The phase shift, remember, is the opposite of here. So in our case, it's, yes, it's to the right 4 pi over 3. I would prefer you just wrote the direction. Okay, it's shifted to the, does that make sense? Because it's upside down, it's starting at its minimum. That's where that 4 pi over 3 comes from. The vertical shift is what right here? 2. That's where the midline would be. Does that seem right if I drew in the line y equals 2? Okay, up 2 we should probably write. All right, the last thing about this graph, by the way, the counting down on the axis is totally ridiculous. It's not evenly spaced, whatever. But I just want to show you one more thing. If we had a minimum at 4 pi over 3 and the period is 8 pi, it should have another minimum at, type on your calculator for me, 4/3 plus 8, and then do a math enter, enter. Or if you're good with fractions, this is 24/3 is 8, so you get 28/3. Did you get that? So it's 28/3 pi, or 28 pi over 3, and that's where it should hit a minimum again. Okay, that's as much as I want to talk about that graph because it's labeled really weird. Okay, to find quarter points, you take the period and divide by 4, and that's the distance between each little chunk. We are skipping. I do want to talk about this. Do you have this on your paper, frequency? I hope I made a note. Did I make a little note for you? Is there a little arrow there? That says 1. And it's on there. You just can't look at my graph. Could you tell that there's a 1 in there? But there is a 1 right in there. The frequency is how many cycles does it finish before the unit 1? This finishes 3 cycles by the time it gets to 1. Notice when we do a sine graph, 1, if this is pi, 1 is way over here somewhere. Has it finished a cycle by, because this is 3.14, right? So we'd have a 1 and a 2 over here somewhere. It hasn't finished a cycle yet, okay? That's why the frequency would be something divided by 2 pi, be 1 over 2 pi. All right, we're going to talk about frequency only in terms of application problems. All right, this one says the B is 1/2. We don't have to factor it because it doesn't ask us to find the phase shift. It only asks about frequency. So we need to find the period. How do you find the period if you know B is 1/2? 2 pi divided by 1/2, which would be 4 pi. Then how do you switch it to frequency? It's the reciprocal, so it's, yes, it's 1 over 4 pi. That's a little tricky. You would need parentheses if you were going to change it to a decimal. And the only other thing this question asks is the midline. Does anybody remember how you find the midline? If you had a graph, perfect. You would find where's that maximum, where's that minimum, and you would average those values. This is not. This is from an equation. The midline is just y equals the vertical shift. So this one is y equals 1. Which is, that's going to be half the graph above 1 and half below 1, okay? Now, what about this one? What's the B? Quickly, B is 3. So the period is 2 pi over 3, which I'm not even going to mess with because I want the frequency. So I'm going to do what? 3 over 2 pi, where both the 2 and the pi are in the denominator. And the midline? The vertical shift is down 2, so it's y equals -2. All right, we're going to get at least one graph done. I'd like to get 2. Here we go. I'm skipping that problem for today. I'm skipping all the way to number 7. Do I want to skip to number 7? Shoot. All right, I want to skip to 7 so that you can do this on your homework. I might have to tape this weirdly, though. Okay. What is A? This has no C or D because it has no phase shift or vertical shift. B is actually, though, 1/4. Does everybody see that? Okay. So the period is 2 pi divided by 1/4, or... So this is what I'm asking you to do. It is a cosine. It starts at its maximum. It doesn't have a phase shift or a vertical shift, so I'm just going to draw one cycle. And what do I want to label it when it gets to the end? 8 pi, right? Now, the amplitude tells us the maxes and mins are where? 2 and -2. Okay, to label the quarter points, I divide 8 pi by 4, which is 2 pi. So the first quarter point here is 2 pi. The next quarter point where it has a minimum is 4 pi, which is actually 4 pi -2, because you do have to write the ordered pairs. This one would be 2 pi 0. And what's this guy over here? 6 pi 0 and 8 pi 2. And I didn't label this one. Should have been 0, 2 if I wrote the ordered pair. All right. I'm going to do one more if anybody wants to stick around. This one is a sine graph. So it looks like this. The amplitude is 3. And the period would be 2 pi divided by 2, or pi. So the quarter points are divided by 4. So this is going to be pi over 4. 2 pi over 4, pi over 3, what does that say? That's 3 pi over 4. That's not what that says. All right, so start working on worksheet 11 and the bookwork.